Hello, everyone. Welcome to Everything Building Envelope. I'm your host, Paul Beers. Everything Building Envelope podcast features topics of interest related to the exterior building envelope, including waterproofing, glazing, cladding, and roofing. We feature relevant topics and guests and want to engage you, the listener, with thought-provoking content. Please visit our website, everythingbuildingenvelope.com, where you'll find access to each episode along with show notes and a special video selection with bonus content. Please subscribe to the Everything Building Envelope podcast on iTunes and Stitcher. We've got a really interesting topic today. It revolves around architectural glass and emerging trends in the industry. Really excited about our guest, somebody I've known for a long time, Jeff Riggett, who works with Viracon in the Florida and Caribbean territory. Hello there, Jeff.
Good morning.
So thanks very much for coming along today, and I know that this is going to really be of interest to our listeners. Before we dive into the topic, could you maybe tell us a little bit about your background?
You bet. First off, Paul, I just want to say thank you to yourself and GCI for arranging the podcast today, and welcome in to all the folks who are listening or will be listening.
You got it.
I started my career, we're dating ourselves here, but back in the 1980s with Conair Company at the time on the metal framing side of the architectural window business up in Atlanta in the Southeast, in field sales. And late in the 80s, I left Conair, went to work for a glazing contractor in Alabama, more or less in the sales side of the business as well, still promoting the Conair product through this glazing contractor. And then in the early 90s, after Hurricane Andrew hit, Paul, there was a need for development of product, as you recall, for the upcoming hurricane codes that were you were heavily invested in time in generating. So Conair came calling, and I went back to Conair to head down to Miami in the early 1990s, around 93 or 94. Again, it was just after Andrew. In an effort to basically spearhead the business development and the design side of all things hurricane impact that were to forthcome with the 1994 South Florida Building Code. And so I did that, for 3 or 4 years. That carried me up to about 96 or 97, and working at the test labs with Conair and developing and testing product and getting it ready for registration in South Florida to do business. I was buying glass at that time from Viracon. We were buying laminated glass to use as infill panels for the hurricane testing. And I had a relationship with Viracon in years past, and always had a great deal of respect for the company and its leadership, and made the transition over to Viracon in about 1997 or 98, and been here ever since, and basically in a business development role here in Florida, and as you mentioned, in the Caribbean too, in sales and marketing, promoting for Viracon. So I've been blessed to work for two pretty good companies in my career, both Conair on the metal side, now Viracon on the glass side.
Yeah, and Viracon, we work with them. We work with them a lot, and they really are one of the leaders in the industry. Maybe you could tell the listeners a little bit about who they are and what they do as far as how they fit into the industry.
Sure. So Viracon, probably the biggest misnomer that I get quite often is folks, particularly architects, think we're a glass manufacturer, and so I'll establish that fine line between the two. We're actually a glass fabricator. The manufacturing of glass is done by names such as PPG and Pilkington, Cardinal here in North America, Guardian, and AGC being the fifth. So those are the folks that melt the sand, Paul, and make the large raw stow sheets of glass that we then take as a fabricator, and then we transform that into value-added products specific to a building facade design, all things such as cutting glass, heat treating it, adding solar energy efficient coatings, which we'll discuss later, laminating it for threat mitigation, whether it be impact for hurricane or for blast or other threats, insulating glass, So all things value added to the outside of the building envelope with respect to architectural commercial glass. Viracon is headquartered in Minnesota. We've been in business now for about 45 years, if memory serves. And we have offices in manufacturing plants in Statesboro, Georgia, as well as southern Utah and St. George. So we have 3 North American manufacturing plants, and then one in Sao Paulo, Brazil, named Glassec. We have a joint venture with a company in Brazil servicing the Latin America, South America, again called Glassec.
So, Jeff, I've been to a couple of the Viracon facilities, the one in Statesboro and the one, forgive me if I mispronounce this, Owatonna. I think I got that right.
Well done.
And they are really impressive. I mean, they're very large, they're state of the art, and I think it reflects the quality of the product that Viracon produces. I know that, nobody's perfect, but Viracon, for sure, in my book, seems to be, one of the leaders in quality. So, you got to give credit where credit's due. So let's talk a little bit, let's get into today's topic, trends in the glazing industry. The thing that really gets, the questions that we get asked a lot now by architects and others is about the energy code. It's a big deal. Obviously, it's a big focus. Buildings use a lot more energy than, say, automobiles do. And there's been a lot of I guess I would say the codes have evolved over time. In Florida, the 2014 Commercial Residential Energy Code brought some big changes to the market, and I was hoping that you could talk about that a little bit, such as when it was adopted and what the changes were, et cetera.
Yeah, sure. It's interesting when you speak about energy codes in Florida. It is a relative new environment for us here. We're sort of behind the 8 ball with the balance of the country that's been dealing with higher energy efficiency on their buildings for a number of years through the ICC. Florida did adopt an energy code in the 2014, the most current code, that enacted actually in July, Paul, of 2015. So it's a 14 building code, but enacted in July of 15. So there's a date to remember. So permits that were pulled prior to July 1st of last year actually would have been permitted under the 2010 Florida Building Code, which there was an energy requirement within that code, but it was not enforced. There may have been some local enforcements, but it didn't become mandatory until enactment of the 14 code, again, in July of 15. And with that enactment came, as you stated, major changes in the energy requirements to we'll keep it for purposes of this call to the building envelope. So windows and doors, fixed glazing in general, now have to comply prescriptively or with alternatively with a whole building energy modeling compliance. And the prescriptive compliance pathway has fixed glazing performing to an SHGC, Paul, of 0.25 and a U factor of 0.50. And basically that correlates to using an insulated and laminated for hurricane impact units. So no longer prescriptively does Florida comply with the energy requirements using just a monolithic laminated impact unit. It would have to be insulated to meet those requirements. Basically, we're asking with
I can remember, like forever, the energy glass that was for energy in Florida was like bronze tinted glass, and this is obviously a big change from that. And people in the industry, I guess even myself included to some extent, didn't have to pay a lot of attention to the energy requirements. But before we talk about the performance path, which you mentioned already, can you just, you mentioned SHGC and U value. Can you just sort of explain each of those values for us?
Sure. So solar heat gain coefficient, or SHGC, basically correlates to the amount of radiant energy that's transmitted through the glass from the solar spectrum, of course, the sun. So in layman's terms, an SHGC of 0.25, we're asking the glass in the window to block about 75% of the radiant heat energy that would be transferred through it, which is a pretty aggressive number. The U factor, I'll step back and point out that the lower that SHGC value, the higher the performance of the glazing. So, for example, a 0.20 SHGC is more energy efficient than a 0.25, if that makes sense. So the lower the number, the better the performance. U value is the air-to-air temperature conductivity through the glazing. It's the inverse of R value. So a glazing U value, let's say an insulated unit with a low E coating has a U value of 0.25. That correlates to an R value of 4. Remember, R value is the inverse of U. So you can right away see that even in an insulated unit with a very high-performing low E coating, a U value of 0.25 is only an R of 4. So glass is highly conductive to air and to heat for that matter. So the SHGC and the U factor are the two primary values in the energy code that MEPs are looking at when they're doing their energy modeling. There are some other things to consider. Obviously, ultraviolet light transmittance, you want to try to minimize that. Not code required, but things that architects should have on their design radar screen. And visible light. You know, you want to be able to balance the proper amount of visible light for the nature and the use of the building relative to the SHGC requirements, whether it be the 0.25 prescriptively or something higher than that if it's done through whole building energy modeling. So you want to balance or right size the visible light transmittance for the building need as well.
Let me ask you another question. You mentioned high performance low E coatings. You know, that's something we hear a lot about, and I just put new windows in my house in Florida that have the low E coatings on them. Can you kind of talk a little bit about well, I guess my first question would be, is low E coating the state of the art these days? And then the follow-up is just, you know, what's it all about?
Yeah, so I'll try to keep that very complex answer short if possible. So bear with me. Coatings, I'll just step back. All coatings relative to glass technology, they're thin film metals that are embedded under the glass surface for energy efficiency. And a little bit before my time, and I think before yours as well. I remember back in the mid '70s, the flash cube reflective buildings that were being designed with these very high mirrored light coatings, which in some instances are still very much used today. The benefit of those coatings, obviously being mirrored in reflectivity, they were negating the solar heat gain transmittance through the glass, but also they were negating valuable visible light transmittance. So they were very good energy performers relative to SHGC, but not very friendly to visible light transmittance. So along came in the 80s low emissivity coatings. Again, thin film technology, more silver-based metals than anything else. And these were spectrally selective coatings, Paul. They enabled the glass, or the coating enabled the passage of the all-important natural visible daylight transmittance, and had fairly good solar heat gain reflectivity, not as high as the mirrored reflectives prior, but it was a good balance, if you will, natural daylight coming through the glass with relatively good SHGC performance. Today, to your question, what would be considered state-of-the-art today, what we see the industry, at least here in the U.S., we see a combination of the two, low E and the solar reflective coatings, and more of a hybrid, if you will, where you get a unique exterior vibrancy or radiancy to the coating, yet you get the natural passage of daylight. So at first glance, some of these buildings, and you're familiar with them throughout Florida, mostly in Miami on the high-rise towers, you get a very vibrant exterior appearance visually, but you can see through the window itself. There's a view into the building into the public space from the exterior streetscape. So they're more of a welcoming type coating, and we can tune, or the market can tune these coatings to the amount of reflectivity that's visually tolerable for the design. So those are hybrid coatings. They're very effective with solar heat gain performance, and they're also very effective for natural visible light transmittance, again, depending upon the nature and use of the building itself.
And you guys have a lot of flexibility with coming up with what the architect wants as far as color goes by blending glass tints and coatings and things like that, and even interlayers, correct?
We do. So one of the things that makes Viracon unique in the marketplace is we're a fabricator that self-performs our own coatings. So we design, engineer, and manufacture both reflective and low emissivity coatings and the hybrid coatings. And we have the ability of doing it in-house, therefore we can apply it to any substrate. So any of the available raw tints that I mentioned the manufacturers produced earlier in the conversation, we can apply it to any of those substrates, and for that matter, multiple surfaces. So we have more flexibility being a self-performed coating company of offering a more versatile package for designers and developers to fine-tune exactly the glass that they're looking for, both visually and from a performance standpoint of their building.
Jeff, going down memory lane, I remember you and I were working on a project in the Caribbean, and the architect said he wanted the glass to be the same color as the bottom of a Coke bottle. That was
Coke bottle green, as I recall, the conversation went, yeah.
But we did it.
We did it. Yeah, we did it. So, yeah, and it's a great point. One of the things that folks know in the industry is that clear glass isn't really clear. There's a iron content in the raw material itself that tends to read a light green tint, thus the name, the Coke bottle green tint of clear glass. So years ago, the raw manufacturers developed what was called low iron glass from a retail perspective, to try to get that ultra visible transparency of the glass, again, from more of a retail perspective. So you hear the term low iron glass thrown around in the marketplace, and that's just that. It's designed and intended to maximize the transmittancy and to reduce that greenish hue that's typical of clear glass.
Clear glass that's really clear. Owners don't like paying for it, though, I can tell you from the times we've looked at it. So retail is good. Little, not so much glass, but if you get a big building, it doesn't always go so well when it gets to budget time.
Paul, it's a great point. When low iron first was introduced, each of these 5 float manufacturers now, they all have their own version. Starfire from PPG, for example, or OptiWhite from Pilkington, there are others. As competition entered, the pricing did come down, but it is still today a premium. And I think it's regionally specific. You see there's such a demand in Florida from a development standpoint of that low entry cost of construction. I would say that the Northeast and even the Midwest, you see more use of the low iron product there, where it's a little bit more accepted from a cost standpoint. But yeah, hopefully you'll see more of it. I'm starting to see specs change where architects they're always pushing the envelope of trying to maximize visible light and transparency in glass. And I am seeing that trend slowly make its way into Florida.
Nice. So we were talking before about the energy code and the prescriptive path versus the performance path. You may have already said it, and if you did, I apologize, but it won't hurt to say it again. Can you tell us what the values are with the prescriptive path, and then what is the performance path?
Sure. So the prescriptive path, again, it's more simple in nature, where it just calls for an SHGC, a fixed glazing of 0.25 and a U factor, which is somewhat different from U value. U factor is the overall thermal conductivity to the glass and the window frame combined, Paul, and the U factor has to be 0.50 for fixed glazing. Those values do change once you get into operable glazing or entry doors. Those values go up or down somewhat, but basically they all would correlate prescriptively into using insulated glass, as I pointed out prior. What I'm seeing more on monumental architectural projects in Florida is the pathway for complying using whole building energy modeling. In other words, invoking an MEP to come in and do an energy study of the building. And what that does, it enables more flexibility in the facade performance numbers that may still correlate over to insulated glass or may not, depending upon the exposure of the glass per elevation and the amount of square footage, what we call window to wall ratio, the amount of vision glass, if you will, to the other cladding materials on the building facade. So, again, in layman's terms, probably the easiest way I can say it is it's sort of robbing from Peter to pay Paul within the building. So you're able to balance the energy consuming entities in the building and have maybe less performance in the facade, for higher performance elsewhere, or vice versa. Again, the whole intent there, compliance with whole building energy modeling, is to design more flexibility into the design and allow a greater range of glass to select from.
Yeah, that makes sense. So what's going on with, we're talking about the energy codes. What, architecture speaking, what are the current fenestration design trends that you're seeing in building facades?
I would say there's a couple that are really going around from a national standpoint. I think the biggest change that we've seen in our business, again, thinking as a large contract commercial supplier, is bigger glass. And I'll come back to that trend in Florida in a minute, but just overall in the U.S., there's a trend to add more glass to buildings, larger panel sizes, which really goes against the energy requirements, where you're trying to add more glass, yet you're saying, okay, we're wanting you to do that, but at the same time, we're placing these very stringent energy performance criteria on that glass that you're designing. So it's challenging us as fabricators and coaters to design and engineer coatings that can ultimately comply with these higher energy standards and in the amount of window to wall ratio that's being required for facades today. So bigger glass for sure. In Florida, with the hurricane requirements, unfortunately, we've had a limit on glass size here, more so from a design performance standpoint of the overall frame, of about 40 square feet per individual light. And I would say that outside of Florida, we routinely are seeing 50, 60, 70 square foot panel sizes being designed. In other words, floor to ceiling glass, again, at points outside of Florida. But back in Florida, with the restrictions of the hurricane requirements and the impact and the cycle testing that's required, the larger glass sizes have a more difficult time of passing, particularly the cycle testing. So I would say that larger glass design trend, while it's I see it in Florida as being something that architects want, it's difficult to give them that because many of the framing companies are not tested greater than 40 square feet or maybe 50 square feet. So the trend is for larger glass, but more companies need to step up and retest their hurricane systems with these larger panels.
We see that same thing in Florida projects. We have, it's a very vibrant market, particularly in Miami. They're bringing in architects from all over the world. Europe, New York would be two places that come to mind the most, but other areas as well. And they come in and they want, just as you said, they want these really large pieces of glass, and we try to do everything we can to work with an architect and give them what they want. They've got the genius of figuring out, how to put things together and have a really great, iconic project. But sometimes you just have to fall back, and you just can't do it with wind loads and windborne debris and things like that.
No, for sure. Working here in Florida with architects over all the years, I sense the frustration at design meetings, particularly from folks that transfer into Florida that are coming from points where big glass was the norm, or bigger glass was the norm, and now there's such a limiter here, and not just in glass size, but in other configurations as well. So, yeah, it's frustrating, but I will say that the good news is that there's hope, that there are companies that are out there, some of the big box companies, Conair and EFCO, YKK and others are testing larger sizes. And then, of course, the regional curtain wall fabricators here located in Florida are also seeing the same thing, that they're always being challenged to design something bigger and better. And so we're seeing 50 and 60 square foot sizes, which is a step in the right direction. We can certainly design the glass to meet and build the glass to meet those sizes. It's what will pass the cycle test ultimately that is the limiter on glass size for here in Florida. And two, keep in mind that larger glass comes with a cost, Paul. So there's a cost premium of using larger glass. Typically anything over 50 square foot in the marketplace starts to get into price premiums from the various fabricators. So designers need to keep that in mind as well.
With the larger pieces of glass, what's the risk with regards to seeing visual distortion, perceptible distortion through the glass? Is it greater than a smaller piece, or how does that work?
Distortion really relative to glass size. I would say the aspect ratio of the glass would play more on that than anything else.
And tell us what an aspect ratio is.
Yeah, sure. So the length to width. In other words, if the aspect ratio, let's say if a light of glass is 6 foot by 6 foot, the risk for distortion there would be a greater, and particularly I'm talking about an insulated unit now, I'll explain, than would be let's say a 4 by 9 panel. That's more rectangular in nature, so it's got a longer aspect ratio, if you will. Again, the width compared to the height. The issue there being in an insulated unit, Paul, for Florida impact compliance, these are unbalanced insulated units. In other words, the inboard light is the hurricane membrane, the laminated membrane. It's typically a pane of glass or two panes that are claved together with and bonded with an inner layer that's about 9/16 inches thick overall. The outboard light is the sacrificial piece of 1/4 inch heat-treated or tempered glass. So you have this large unbalanced insulated unit where the center light is to the outboard, and in an insulated unit, that air cavity, that hermetically sealed air cavity is constantly changing, both in pressure and in temperature. So you have an inward and outward flexing of the glass. And you can imagine the more square and larger a piece of glass is, with that center light outboard, it's actually taking the bulk of that stress in that sealed unit. So you get some concavity or convection outwards where images and reflection, Paul, will be distorted. And we're seeing that particularly on the more reflective, I mentioned earlier, the more radiant building facades. So something to note architecturally, if you're designing larger glass sizes, particularly here in Florida, you have an unbalanced insulated unit. What I would recommend doing to mitigate that risk is to use a thicker piece of outboard light, maybe a 5/16 or even a 3/8. Of course, it's cost relative, but again, depending upon the size of the unit, I would highly recommend walking through the thicker glass to the outside to balance that unit and try to minimize that pressure differential in the air cavity.
The reason I brought up distortion was because we see it all too often on projects where large pieces of glass, or as you say, with aspect ratios that promote that, and you've got multiple pieces of glass, you've got a laminated glass inner layer, you've got a high performance coating, you've got an airspace. Who knows, the framing sometimes can have an effect on that, and we're seeing it. It's a shame. We see it a lot more than we should, and it can either result in a very expensive problem in replacing a lot of glass, or you can have a lot of very unhappy people. And I recommend, like you recommend all the things you can do. I recommend paying a lot of attention to that, because it comes up at the end of the project also. One of the last things that go in is the glass. Well, maybe not the last thing goes in, but it goes in relatively late in the project. It's dirty, it's not cleaned. It may have protective film on it. They clean it up, take the film off, ready to open the building, and we have a problem. And it could be a very, very big problem.
Well, honestly, we could spend this entire podcast to talk about distortion, and you're right. And maybe this is a topic that we'll come back and visit. I would only say in broader terms that, to your point, here in Florida, distortion and glazing is basically an inherent fact of life. It's just part of the deal. To your point, you're using a laminated glass unit with multiple glass plies bonded with a plastic interlayer of any given thickness. You've got heat-treated glass, and you've got an insulated cavity that's moving under the exposure to the sun, different temperatures throughout the day. So there's so much going on there that you add in the aspect ratio we discussed earlier that, you really want to pay attention to not only the glass design, but certainly the glass fabricator, the coatings that you're choosing. Obviously, we've seen an uptick in visual mock-ups to demonstrate the quality of the glass prior to ordering certainly any large projects. That's become more the norm to get architectural and owner buy-in of the look prior to ordering the balance of the glass. And really it just boils down to having a conversation, as you just pointed out, with the clients. And if you see them going down a path that could be problematic in both sides, or perhaps a particular coating, there's coating uniformity concerns that need to be discussed as well. Consult them through that, talk them through the do's and the don'ts, and then ultimately let them vet that out. And quite frankly, some of this just comes about through a trial and error and experience. You hope that you don't repeat the same thing twice. I know, speaking for us here at Viracon, we stringently monitor all aspects of the fabrication process to ensure that we get as flat a glass as possible on the building. But inevitably, heat-treated glass is going to have a roll wave to it, and then you put a reflective coating on it, you insulate it, you laminate it, and then you put another building adjacent to it that you're reflecting off that skin, and distortion can happen, and in fact will happen. But deal with reliable people, and hopefully they can walk you through the concerns. You look at the mock-up, vet that through, and I guess in hindsight, the best I can say, it's a process. Just make sure you're dealing with quality people.
Yeah, because the ASTM specifications that cover flat glass and heat-treated products and whatnot, one of the things they say up front is that all glass has some degree of distortion. And people probably don't realize that, but it's the degree of distortion and whether it's perceptible or not. You certainly don't want to be looking out through a light of glass and have it look like you're at the fun house at the carnival. So it's a big deal, and we're seeing it, as I say, more than we'd like to. So let me ask one last little line of questions, and I think
Sure.
we're getting ready to get into the end of our time limit. We're all flying high right now. GCI Consultants is very busy. I know Viracon's very busy. I know the glass industry is very busy with longer lead times, opening factories, things like that. What do you see, and what does Viracon see with the current business climate and what's coming down the road?
Yeah, well, thankfully you're right. At least here in North America, we've been blessed with a very active commercial building market, and look to continue that for the several years to come. In our forecasting, we see a positive trend upward through 2020 in our core market here domestically. But it's an interesting question, because frankly, the run up that we're in now, if you recall, sort of caught the market here off guard a couple of years ago, coming out of the downturn that we experienced in 9, 10, and 11. We wrapped up a lot quicker in the marketplace than most folks perceived, ourselves included. And so a couple of years ago, folks were dialing down capacity because the demand obviously was quite low at that time, and then had to rapidly dial it back up as demand increased. And so it took about a year and a half, speaking more internally of Viracon, to get capacity in line with the demand. And we're in a good place today with respect to, our core market. I think the industry in general, the capacities today are meeting the demands, again, relative to the specific businesses of these fabricators. We have a longer-term perspective at Viracon because we're dealing with bigger buildings, bigger projects that have more scheduling awareness, and so we have the ability of predicting the backlog a little bit better than someone, for instance, building a 7-Eleven down the street on the corner that may need glass in a week or two. But I think on balance, if you're a developer or a builder, whether you're dealing with a big major fabricator like Viracon or a regional local guy, I think that there's glass available for you in the marketplace in the time frame that you now need it. I couldn't say that a year and a half ago. Again, in the run-up, there was definitely a capacity constraint. But as I said, we're in a much better place now. I see that continuing, as I mentioned earlier, for the next 2 or 3 years. Here in Florida, I think we mirror the balance of the country. The run-up for us has been more on the residential side, particularly on the high-rise side. That has started to slow down somewhat, and I think that will be augmented now with the commercial and retail that will build in behind it. So the market itself in Florida may change relative to sector of the construction project, but I think overall it will still be a brisk for us going forward.
Yeah, we're seeing similar in our business in Florida and also the Southeast and other areas, Caribbean and even other parts of the country, where condos, while they're not going away, seem to be slowing down a little bit. We're seeing a lot of multifamily still, and we're starting to see office buildings now as well. We've got a couple of LEED Platinum office buildings that we're working on now that are more recent additions to our portfolio. And we're busy and stuff is still coming in pretty rapidly, but as we all know, it's cyclical. And at some point, we keep looking, having been in this business for so long now, when's it going to slow down? Haven't seen that yet, but we know it's coming at some point.
Yeah, I would agree. I'm not. I know at some point down the road we'll all probably plateau out and see maybe just a flat line. I certainly don't expect the downturn that we experienced prior, God willing. But probably the one thing that I could say to finish up and wrap up from a contracting standpoint relative to the market demand today, particularly on the large projects, buy the glass out quickly. The years ago there was a trend to wait and buy it late, and I would say that would have gotten you in trouble, and certainly would have gotten you in big trouble a year and a half ago. So make sure that as a contractor you're doing your due diligence to get that glass package bought out quickly, get the aluminum and the glass booked and forecasted at the prospective manufacturing companies, and put it to bed, and then move on to the other trades in the company. And that's probably another trend that I see growing, is a more rapid buyout of the glass package, knowing that there could be another spike in demand and perhaps a capacity issue down the road. But not only does it lock in your capacity for your job and allow you to meet your schedule, but it also locks in pricing. So obviously, costs and scheduling are all important to a contractor. And again, I would just say to try to get on that as quickly as possible and get that bought out.
Good stuff. Well, Jeff, thank you very much for coming on board today. It was really interesting and fascinating. I know our listeners are very interested in the energy, and the explanations are good. Sometimes it seems like voodoo to some of us. So thank you for making it understandable. And I'm hoping that maybe we can do this again. I love the idea about talking more about distortion. I also love thinking about glass damage, scratch glass, things like that. That would be something everybody really needs to focus on. So thanks so much for being with us today. Really appreciate it. And it was good stuff.
Thanks for having me, Paul. Happy to be here, and for sure I look forward to continuing other topics down the road.
So this concludes this episode of Everything Building Envelope podcast. Hope you found it interesting and thought-provoking. Please subscribe to the Everything Building Envelope podcast at iTunes or Stitcher, or visit everythingbuildingenvelope.com, where you'll find show notes, previous episodes, and bonus content videos. As an added bonus for visiting everythingbuildingenvelope.com, we've added a free white paper that's germane to what we talked about today. It's called What You Need to Know About Energy Codes and Recent Trends for Glazing Systems. Energy code requirements are evolving, and it's very important to keep up with these new developments. Thank you, everyone, for listening. Please tell your friends and colleagues about Everything Building Envelope podcast. This is Paul Beers saying so long until next time.